This is problem 7 of the 2022 MMATHS Individual Round, and the problem reads, Catherine makes Benj play a game called 50 Cent. Benj starts with 50 cents, and every century thereafter has a 50% chance of doubling his money and a 50% chance of having his money reset to 50 cents. What's the expected value of the amount of money Benj will have in dollars after 50 centuries? Okay, so basically we have a game, and rather than think about all of this centuries distractions, we're just going to imagine it's played for 50 rounds. And what Benj is going to do, he's going to start with some amount of money. And every round, he's going to flip a fair coin, for example. And if it comes up heads, he will double his money. And if it comes up tails, he will have his money reset to 50 cents. Right? And after 50 iterations of this game, we want to find the expected value of the amount of money Benj will have in each case. All right. So rather than start out from the beginning and just play games, we're going to start out from the end after the game. And imagine, like, let's say these are 50 iterations and I'm just marking down the results. After the 50th iteration, you look back at the game and you say, hey, when's the last time I flipped a tail? When's the last time I had my money reset to 50 cents? And that's the unique statistic that will define how much money Benj will have. So let's say this is the first state, second state. I'm going to label some of the rounds. So this is 49, this is 48, this is 47, this is 46. And you can imagine this is a list of 50 outcomes where each outcome is a double or a reset. So that leaves us with the question, well, what's the probability that the last reset comes on the 50th turn? So let me make a table. Last reset 50. Now, what's the probability that this happens? Well, the probability that this happens, well, it happens with 50% chance, because on this 50th term, there's a 50% chance that you double your money or a 50% chance that you go down to 50 cents. So the probability that that happened is 1/2. And how much money does Benj have in that case? Well, he was just reset to 50 cents on the last try, which means that he has 50 cents. Okay, now we can sort of fill in some more spots on the table by imagining the last reset was here, meaning he definitely doubled here and reset there. Well, what's the probability that that happened? The probability that he had a double on the 50th turn is 1/2, and the probability that he had a reset on the 49th turn is 1/2. So the total probability that this happened was 1/2 times 1/2, which is 1/4. And how much money does he have? Well, here he's been reset to 50 cents on the 49th iteration, and then he will double his money on the last turn. So he will have $1. And we can sort of fill in the table as well. What if the last reset was 48? What's the probability that that happens? Well, more particularly, if the reset was on the 48th and then he doubles on the 49th and the 50th turn, each of these three events happens with probability 1/2, and you can multiply those three together because they're all independent. The probability of reset double is 1/8. And how much money does he get? Well, he resets to 50 cents and then doubles twice, so he has $2. And we can use the exact same logic for if his last reset was 47 and the probability that that happens is 1/16, and the amount of money he gets is $4, using the exact same logic. And you can sort of see some patterns forming. Like for every time you go back a slot for the last reset, the amount of money he gets doubles, but the probability that that happens halves. So for example, if the last reset occurred in spot 2, meaning that Benj got incredibly lucky and doubled 48 times after this, then the probability that that happens is the probability that he reset on turn 2 and then got 48 straight doubles. That happens with probability 1/2 to the 49. And how much money does he get? Well, he had 50 cents and then he doubled it 48 times. So 50 cents times 2 to the power 48. If his last reset was 1, similarly, the probability that that happens is 1/2 to the 50, and the amount of money he has is 50 cents times 2 to the 49. Finally, there's one last case we considered, which was that he did not get a single reset. He was so incredibly lucky that he got no reset. What's the probability that that happened? Well, the probability that that happened is just the probability that every one of these 50 turns he doubled. So if all of these guys are D's, what's the probability that that happens? 1 over 2 to the power 50. And how much money does he get? Well, 50 cents, and then he doubles it 50 times, so 2 to the power 50. All right, now that we've made our table, how will this help us? Well, it turns out that in order to calculate expected value, all we need to do is find the expected earnings from each case and sum them all up. In particular, the expected earnings from the first case is 1/2 times 50 cents, which is 25 cents. And the reason is because half of the time he will get 50 cents. So you multiply 1/2 by 0.50. And similarly from this state, where the last reset was at the 49th slot, he will get 1/4 times $1, which is 0.25. And similarly, in every single case up until the last one, he will have an expected earnings of 25 cents because the probability halves, the amount of money doubles. So the expected value for this case is 0.25 as well. If the last reset was on the first turn, the expected probability is 0.25. If there's no reset at all, if he just doubles his money 50 times, this is a little different. It is 50 cents, but the reason is because that you did not have this probability. And so you just end up with 1 over 2 to the power 50 times 0.5 times 2 to the power 50. Now, all that's left to do is to sum out all of these expected earnings, because that's how you calculate expected value. So how many states are there that had that contributed 0.25? Well, it turns out there are 50 of them, because if there ever was a reset, that would contribute 0.25. So 0.25 times 50 plus our final state, which is 0.5. You end up with, well, 0.25 times 50 is 12.5 plus 0.5, which means that his expected earnings after 50 centuries is $13. And that is our final answer. Thanks for watching, and I will see you next time.